Okay, so welcome back. Now, in the last video, we talked about finding the perimeter of the Koch Snowflake. Okay, and so it might have been a surprise that the perimeter was going to infinity. But that's the thing about some of these infinite series that we come up with. It's not always easy to tell where they might be heading, whether they converge and diverge. So I'm going to reiterate the fact that we've got to use analytical approaches because our gut feeling or what we think it might be happening might be incorrect. Okay, so keep that in mind when you're working with infinite series or infinite sequences for that case, and rely on the techniques and the methods that are being presented in order to come up with the correct conclusion. Okay, so now we are going to turn our focus to the area of a Koch snowflake. So we're going to start with the different iterations. We're going to define things in terms of f sub n, the nth figure, and then take the limit of that formula, if we can come up with one, and see where it goes, and that should lead us to a conclusion about the area. Okay, so let's first denote some things. So first of all, let T sub n equal the area excuse me, of the nth figure f sub n. Now, f0, as we said before, is an equilateral triangle. Okay, what do we know about equilateral triangles? Well, all the sides are the same and all the angles are the same, which means the base angles are 60 degrees, all the angles are 60 degrees. And so we can find the altitude of an equilateral triangle, right? Easily, because we can use a bisector, right? So we can draw an altitude that bisects the angle and we get a 30, 60, 90 triangle. And so we can find that the height of the triangle is going to be what? We can find that this is going to end up being 2, 1, and the square root of 3. Okay? Why? Well, 1, we know that the so this is again the general unit, right? So if this was the case of an equilateral triangle, we have 2, 1, and square root of 3. Okay, so now, how does that help us? Well, we got to find the area of the triangle, right? Well, if f0 is an equilateral triangle, we already know that the length of each side is 1, which means that all of these are going to be divided by 2. Okay, so that means this is going to be 1, this is going to be 1/2, and this is going to be the square root of 3 over 2. Okay, right? Okay, so now T sub 0 then is the area of this triangle, which means that this is the base, which is 1, and the height is square root of 3 over 2. So the formula for the area of a triangle is 1/2 base times height. So it's going to be 1/2 times the base, which is 1, times the height, which is the square root of 3 over 2, which gives us the square root of 3 over 4 as the area of the first figure, f sub 0. All right, good. Now, for n greater than or equal to 1, what do we have? Well, since the lengths of the sides of the new triangle are 1/3 of the length of the side of f sub n minus 1, right? So again, if you go back to the diagram, again in your notes or in the textbook, or if you looked it up on the internet, if you look at the diagram of the Koch Snowflake or different iterations of the figures, you notice that you're increasing the area, right? And by replacing 1/3, the middle third of each side of the triangle, by another isosceles triangle that points outward. And so that means that the triangles, the sides of the triangles are 1/3, the new triangles are 1/3 of the side of the triangle before it. Or excuse me, I should say the figure before it, because only the first one represents a triangle. But that's what's going on here. Okay, so since the length of the sides of the new triangle, the triangles that are being created from the sides of the from the previous figure, okay, so those sides are 1/3 the length of the sides of f sub n minus 1. Then we can have this. Okay, so we can rewrite t sub n, the area of the nth figure. Okay, so for n greater than or equal to 1, we have t sub n is going to equal 1/3 of what? It's going to be 1/3 squared times the area of n, or t sub n minus 1. Okay, so therefore, what do we get? Oh, not n, sorry. Didn't want to put n there, should be, it's 2, not 2. Okay, so this is the recursive relationship for the area of each subsequent figure from t sub 0. Okay, so now what happens? If we keep doing this, if we keep replacing this, right, with t sub n, right, 1/3 squared, so this is going to be 1/9. So let's make this into 1/9 t sub n minus 1. Okay, so t sub n is equal to 1/9 of t sub n minus 1. And what happens if we keep doing this, if we keep replacing this with what? T sub n is going to be 1/9 of t sub n minus 2, and then t sub n minus 2 is 1/9. And how many times can we do that? Well, we're going to do that n times. So we can rewrite this as 1/9 to the nth power times t sub 0. Which again, t sub 0 is square root of 3 over 4. So this is going to end up being 1/9 to the nth power times the square root of 3 over 4 is going to be our area of the nth figure, f sub n. Okay, so now therefore T sub n equals this, and since a new triangle is formed on each side of f sub n minus 1. So this is what we have for T sub n, okay? Now remember, what does T represent? It denotes the area of each new triangle created when forming f sub n. Okay, so we have to understand what this means. So this is the area of the first triangle, but T sub n for n equals, for n greater than or equal to 1, each T sub n is the area of all of the new triangles, that are created, okay? So how do we get this? Well, remember, each new triangle has a third of the side of the original triangle, right? So starting with the original isosceles triangle here, we know that from this point forward, all the new triangles that are being added to the figure are going to have a side of 1/3. Well, then if you calculate the area of each one of those triangles, you get this expression right here. Okay? Because this ratio doesn't change, because each isosceles triangle is still going to have the same ratio of sides. It's just that the length of each side is reduced by 1/3. So then you get this. Okay, so understand that T sub n represents the area of all of the of each new triangle. Okay. Okay, so again, that's just so everybody is on the same page. Okay, so now, how do we use this to get area of the whole figure? Okay, so since a new triangle is formed on each side of the previous figure, we've got to relate this to the number of sides of the previous figure. Okay, so that's going to be n sub n minus 1. Okay, so a sub n, so the area of the nth figure is going to be what? It's going to be the area of the previous figure right? Plus the area of the new triangles that are added times the number of sides of the previous figure. So this is going to be n sub n minus 1. That's the number of sides on the previous figure. And that's the number of rectangles, not rectangles, the new isosceles triangles that are going to be added. So that means that we're going to take that times T sub n. Right? Okay, now, we already know the formula for the number of sides, right? And we know this formula for T sub n. So let's plug those in. Okay, so in this case it's, excuse me, the number of sides is going to be equal to a sub n plus, this is going to be 3 times 4 to the n minus 1 power. Okay, we got that from the previous, with our work on perimeter. Okay, and then of course T sub n is 1/9 times, or 1/9 to the nth power times the square root of 3 over 4. Okay, okay, so now let's simplify this. So a sub n, oh, hold on a second. I'm sorry, this should be n minus 1. It's the area of the previous figure. I think I said n minus 1 but didn't write it. Okay, so now let's simplify this and rearrange this. So we got, here we got n minus 1 let's divide this by 4. Let's multiply the top and the bottom by 4. So let's put a 4 here. And so if I multiply this by 4, if I add another 4 here and then divide by 4, it'll cancel each other out. It'll be, multiplying by a form of 1. So because I want to make this n. So I need to get another 4 in here to make this n so I can combine it with this one. So I'm going to divide by 4 to cancel it out. Okay? So this is going to be 3 over 4 times 4 to the nth power now. And then this is going to be 1/9 to the nth power times the square root of 3. Oh, wait a minute, wait. Can I do something else there? Is that right? Okay, no. I was thinking, I have this 4 here, but I still have to, I would still have to do this. So, okay, so now let's go back up here and see what happens. So now we've got a sub n equals the area of the previous figure plus, what do we get now? It's going to be, keep dropping things. Sorry, so this should be equal to a n minus 1 plus that. Okay. So a sub n minus 1 plus, so this becomes 3/4 times 4/9 over n times the square root of 3 over 4. Okay, now, I can combine these, right? And what's going to happen here? Let's see here. Okay. Okay, let's see what happens here. So if I say a sub 0, right, the area of the first figure, we already know what that is because it's t sub n, right? So t sub n, or t sub 0, which was equal to the square root of 3 over 4, right? Well, at t0, this becomes 1. Oh, I'm sorry, this is just divided by 0, so we're not there yet. So for n equals 1, this is for, let me put this, So again, just not to forget, so this is for n greater than or equal to 1. Okay. So we know that a sub 0 is equal to this. So now a1 is what? Well, it's going to be square root of 3 plus 4 plus what? Well, at 1, it's going to be 3/4 times 4/9 times the square root of 3 over 4, okay? Which this cancels with this, right? And this, this becomes what? The square root of 3 over 4 plus, well, this becomes 1/3, right? So 1/3 times the square root of 3 over 4, right? Okay, which is true, but let's do this a little bit differently. Let me see here. Oh, let's go back to this. Okay, let's rewrite this, because I don't want to cancel things out because we're going to miss information here. So this is going to be square root of 3 over 4 plus, then this piece here is going to be 3/4 times 4 ninths, right, times the square root of 3 over 4. So notice that we have, well, you know what? Let's keep going before I do this. So if we do a squared, or excuse me, a sub 2, well, that's going to be a sub 1, which is going to be this, square root of 3 over 4 plus 3/4 times 4 over 9 times square root of 3 over 4. So that's that piece, right? So a sub 2 is going to be a sub 1 plus, well, this piece with 2. So this is going to be plus 3/4 times 4/9 squared times the square root of 3 over 4. Okay, so that's a2. And then, what else? Okay, so notice what's going on here. Okay, so here we've got a common factor of square root of 3 over 4. Even here, square root of 3 over 4. Okay, so let's see what we can factor out. So let's write this as square root of 3 over 4 times, you know what, hold on a second, let's, times, and then what's left over when we factor this? We get 1 plus 3/4 times 4 over 9. Okay, so that's that one. And then a sub 2 becomes what? Well, we're going to factor out the square root of 3 over 4. And so then what does that leave us? Leaves us this. So 1 plus 3/4 times 4/9 plus 3/4 times 4/9 squared. Okay. Now, is there anything else that we could do with that? Well, notice what's going on in here. So we factored out the 3, so here we get 3/4. So in fact, we could just write here. Oh, here. Right? So a sub 0, we get square root of 3 over 4 times 1. You could put a 1 in there. And then a1, we get square root of 3 over 4 times the quantity 1 plus this, right? And then the a sub 2 gives us this, right? Where now we end here at 3/4. So now, how can we deal with this? Well, notice this here has a common factor of 3/4 because it's kind of hard, well, what to do with that 3/4. So let's go one more step, right? Because for this piece, except for the first one, because I was like, well, what are we going to do with that 1? Well, in this case here, we've got this 3/4. Why don't we bracket this off? Okay, so for all of the terms other than the first term, we have a common factor of 3/4. So let's do this. So if we take all of this into consideration, then the a sub n, right? So a sub n, we could write it this way, right? So this is 2, 2, 1, 1. So it seems like the nth term, right, we're going to have to the nth power here. So if I write a sub n, that's going to be equal to square root of 3 over 4, right? And then I'm going to put in brackets 1 plus, and now what I'm going to do is I'm going to factor out the 3/4. And then now what's left over when I factor out the 3/4 is going to be 4/9. Yeah, I could even go further than that, but yeah, let's just stick with this. So I'm going to do 4/9 plus 4/9 squared plus 4/9 cubed plus all the way to plus 4/9 to the nth power. And so that's what I end up with. Okay, now we can focus on this. And what do we see in there? Well, that's a geometric series, right? And so what I was going to do, and I'll do that now, is we can factor out one of those 4/9, right? Because that's your a value, okay? So that's what I was saying, and that's why I paused earlier, is like, I could do one more step. But I said, well, let's just wait. So I can factor out a 4/9. And if I factor out the 4/9, then it will look exactly like the geometric series that I need. So again, if I factor out the 4/9, so let's go back up here. So again, make sure you have this in your notes. Okay, so now we've got this general form. Okay, so now, where does this take us? So now, watch what happens. If I factor out a 4/9, now I'm going to end up getting 1/3 out here. Okay? So I'm going to write a sub n equals the square root of 3 over 4, okay? And now I'm going to have 1, now I'm going to factor out the 4/9, and I'm going to get 3/4 times 4/9, which is going to give me 1/3. And then now what I have in brackets is going to be 1, oops, sorry, trying to, So I'm going to have 1 plus 4/9. Oops, not 4 over n. 4/9 plus 4/9 squared plus all the way to 4/9. Now it's n minus 1. Okay. And now we can write this as a geometric series, because now we've got the A, right? Here's our A, and now what's the common ratio? 4/9. So we know this is going to be a convergent geometric series, because r is less than 1. Okay? So now, how do we solve for this? Okay, well, remember this piece right here, here, this is your A, this is your 4/9, or your R value. Okay? So now, this is a geometric sum. And so this here, this piece here, let me bracket this off. Okay, so that piece there is going to be equal to 1 minus, well, let me do it in a different color. Yeah. So 1 minus 4/9 to the nth power over 1 minus 4/9. Let me double check that. Okay, so now what do we get? Well, so this reduces to, so now we can write this a sub n as equal to the square root of 3 over 4 times 1 plus 1/3 times 1 minus 4/9 to the nth power over 1 minus 4/9. Okay, now this, remember, this came from the geometric sum earlier. Remember here, so just to remind you, remember the general form when we were talking about geometric sums before. We said that it was 1 minus r to the nth power over 1 minus r. Remember that? Okay, so that's where this is coming from. So don't forget, this is a geometric sum. And so the formula for a geometric sum is 1 minus r to the n over 1 over r. And then we said, is r less than 1 or is it greater than or equal to 1, right? And so if it's less than 1, then this is going to 0, right? And so it reduces to 1 over 1 over r. Okay, so that's what we're doing here. Okay, so this is 4/9, right? So again, since this is convergent, this is going to go to 0, and we end up with the same expression that we had before, which is going to be 1 or a, right? Remember the a over 1 minus r, but in this case here, for this piece right here, a is just 1, right? So the leading coefficient. Now I call a 1/3, but again, it doesn't really matter because it's just multiplication. So if you use this sum here, then a is 1, but you could multiply through by 1/3 and then a becomes 1/3. So that way, again, it's 6/2 of the other, okay? So in this case, a is 1, right? If you just focus on what's in the parentheses, a is 1, right? So then it's 1 minus 4/9 to the nth power divided by the quantity 1 minus 4/9, which is again that expression there. So again, don't forget the general expression for geometric sum for all r, right, is 1 minus r to the nth power divided by the quantity of 1 minus r. Don't forget that, okay? And then if r is less than 1, if the absolute value of r is less than 1, then this thing reduces to 1 over 1 minus r, okay? If r is greater than 1, then this thing goes off to infinity, or negative infinity, and it diverges, okay? Okay, so now, enough of that. Okay, so now, where are we at? We are here. Now, again, because this is r is less than 1, right? Again, you can simplify this. Okay, so now let's simplify this. And what do we want to do with this one? Okay, so this becomes square root of 3 over 4. And what do we get? We get okay, so 1 over 1 minus 4/9 is going to be what? 5/9, right? Because 9 over 9. So this is going to be 5/9. So this is going to end up being 1 plus 1/3 times, well, it's going to be 1 over 1 minus 4/9, right? I'm going to split this up into two fractions. Minus 4/9 to the nth power over 1 minus 4/9, right? And so again, I'm just simplifying this, okay? And so what happens? Well, this becomes square root of 3 over 4, and this is just going to be what? 1 over, this is going to be 5/9, so 1 plus 1/3, and this is going to be 1 over 5/9 minus 4/9 to the nth power over 5/9, right? And then, okay, we're almost to the end of a sub n. So what is a sub n? Well, let's just keep simplifying this. So this is going to be the square root of 3 over 4. Now, this is going to become 1 plus 1/3 times, well, this is going to be 9/5, minus 9/5 times 4/9 to the nth power. Okay, we're getting there. So this is going to be the square root of 3 over 4. And then what happens here? Well, yeah, we're just going to distribute. So this will become 3/5 minus 3/5 times 4/9 to the nth power. And now this becomes the square root of 3 over 4. And it's going to be what? This becomes 8/5 minus 3/5 times 4/9 to the nth power. Okay. So now, that's how we represent a sub n. So there's our formula for a sub n, the area of the nth figure. So now, if we take the limit, okay, so we take the limit as n approaches infinity of a sub n, what happens to this? What happens to it? Well, as we know, this whole thing is going to what? Zero. Right? We already said that. So this is going to 0. And we could have done this, by the way, we could have done this way at the end, the further back when we had the expression for the geometric sum. We could have done it the limit then, but they wanted to make sure that we had an expression for a sub n because that was part of what they wanted. They wanted to have an expression for the area of the nth figure. So that's what this is, okay? But we could have gone right to the A, right to the area of the Koch snowflake. So again, we just call this A, right? The area of the Koch snowflake, okay? But nonetheless, you get the same answer because this thing still goes to 0. You're left with the same thing, 8/5, right? And so in this case, what do you end up with? You end up with the square root of 3 over 4 times 8/5, which then equals, well, this goes to 2, so you end up with 2 times the square root of 3 over 5. And that's the area of a Koch snowflake. When you start with an equilateral triangle that has equal sides of 1 unit, that's the area of the resulting Koch snowflake. Okay, that's it. Have a great day.